So today what I had in mind was talking about this tidy single cell experiment package and really more generally. So I went to this conference called GBCC. So it was like Galaxy and Bioconductors together. And this conference, as well as like a couple of years ago, this is sort of like an effort from like Mike Love, Stefano Mangiola, and some others. So at the last conference, GBCC, we had like a workshop and we were talking about just the general effort of bringing sort of the tidyverse to bioconductor packages. So some of these are like summarized experiment derivatives, which is what I'm basically focusing on today, but it is a broader effort. So like generally trying to treat bioconductor objects as like data frames, sort of like, or being able to interpret certain parts of the object as data frames, and work with them with like dplyr verbs and stuff like that. But yeah, today I'll be focusing on single cell experiment packages. I know a lot of us use that. And so, yeah, the general idea is that, I mean, it's sort of like treating by default, it's sort of like prints the single cell experiment object prints a tibble of the call data, and you can manipulate it like you would in dplyr or tidyverse. So basically what they had done here, or what Stefano had done here, is implement all the, well, I think it's all of the dplyr, at least that's what's claimed here, all of the dplyr functions to operate on or to operate on single cell experiment objects, as well as some tidyr, actually all tidyr functions. So I guess that includes your pivots and stuff like that. Then ggplot. So you can actually plot single cell experiment directly. And then plotly, which I have used plotly in Python R. And so they also added a couple of utilities where you can directly convert to a tibble. And then I'll sort of show disjoint features, which is like, by default, it only gives you your call data in the tibble. So this would give you particular genes as well into a long format, which I'll show actual examples of in a bit, as well as a suitable booking function, which I haven't really explored that too much. And I know there's other alternatives, but so yeah, I'll just kind of go through this vignette here. So I have this loaded, all the R functions loaded and over here. And so let me actually load R here, make this a little bit bigger as well. So let's just load some of these packages. They use a bunch of the packages here. Just go ahead and load those. And so we'll be working with like this example small object that they provided as part of the package. And so let's just take a look at this object. So this object is a single cell experiment. There's nothing at all different about it. So the reason it prints like this is because when you load the tidy single cell experiment package, they override the print method to operate and to print different information here. And so it prints it like it's a tibble. This was sort of unfamiliar. Like I wasn't exactly sure how this works, but the way they described it is it's like an abstraction. So it's not really printing, from my understanding, it's not actually making a tibble. It's just somehow printing the information as a tibble, but that I'm a little shaky on still. But you can see what gets printed here is you have your set of cells. So basically you have columns, and the others are columns of the call data. So that's just what prints by default. And again, you can join in features, but that's not in here by default. And so you can do anything you want, use any dplyr functions you want to manipulate this as if it were a tibble, even though it's technically a single cell experiment. So yeah, I guess just to be extra clear here, this tidy single cell experiment is not a class. So it's not defining a new object. You can use existing single cell experiments as they are. You're not changing their type or anything. It's just providing, and I can show this here actually, it's just providing functions from dplyr, tidyr, ggplot stuff. So over here, if we actually look at the reference functions, you can see that they went through and they have all these functions. Most of these functions are from dplyr, really. So you can see stuff like distinct, filter, your different types of joins, so full join, inner join, left join, group by, any sort of dplyr functions they have manually implemented for single cell experiment objects, and so they define the behavior for single cell experiments. So I guess that's the background, and we can actually go into some of this vignette here. So if we take a look at the assays, nothing's really weird here because again, this is not a new data type. It is simply a single cell experiment. So you can take a look at the assay, the counts. They do give this option where you can basically, if you have the package loaded, but you actually want to print things normally, sort of show single cell experiments as they're normally shown, you can configure that as an option so that when you print, now it looks like what you normally see when you print a single cell experiment object. So that's configurable. I'm gonna turn it back on because we'll be using this type of visualization from the tidy package. Most of this, I'm gonna go back to this vignette actually because it's explaining more of what we're doing here. So yeah, I guess one of the reasons I'm actually running this interactively is because I think for whatever reason, there's like sort of buggy printing in their vignette. So it's kind of difficult to see some of these things. So we went through this. The first example that they provide here is that like one of the call data columns is a file. We don't have the sample information yet, and they want to extract the sample information from the file. So normally in base R, you could sort of use like manipulate. You could create a new column in the call data with the $sign syntax and sort of manipulate this file to sort of extract the sample. But you can also, with this package, they're using the dplyr verb extract, or I think it's dplyr. I haven't actually used it, but they use extract here. And so that's creating a new call data column and then adding it to a new object. And even though it's sort of operating on a data frame, actually, let's go back here and I'll show this. So we have so let's do this here. So we added this sample column. I guess it's over here, but extracting like sample 1 or sample 2 stuff. And it's a new column in this object. And to be clear, it returned a single cell experiment. It did not return a tibble. So you can actually assign that, like they assign this to a new single cell experiment object. So it's like you're manipulating it like it's a tibble or a data frame, but the whole time it's just a single cell experiment. So of course you can also use select here. They just reorder the call data columns using select. And so that puts sample up front here. And actually, let's just do this just to show as an experiment. So let's just define a variable here, a temporary variable. So like I said, when we apply these dplyr verbs, we're returning a single cell experiment. And if we actually look at the call data, you can manipulate this just like it's a single cell experiment. Of course, you don't have to use this, treat it like a tibble. So in the call data, after reordering using the dplyr verb, we have the call data column sample up front. So yeah, a bunch of different ways to view your information here. I'm gonna skip over this. So yeah, we can also do some plotting. I'm not gonna skip that. I'm just gonna skip, like, I don't think we need this custom theme that they use. And so yeah, just to make sure we're clear in this is plotting number of features for this cell. Okay. So making sort of a histogram of, it looks like in the call data, there's already a variable for number of features. I think this is like features with non-zero counts is what I'm assuming this means, which is in this column down here. And so let's go ahead and use ggplot directly on this single cell experiment object. So I'm going to, from last time, I believe this should make a rplot. Yep. So since I'm doing this on the cluster and I'm not using X11, I'm going to open up this rplots thing that gets generated. And so this is what the plot would look like. So yeah, this is just a histogram of like the number of features across 2 different groups. So yeah, you can directly use ggplot basically, and you're operating on the call data of summarize experiment by default. So I think this is a similar plot. Let's see, we can go ahead and plot it. Too small. That's funny. I didn't know. I'm using Radian, I guess, for the first time today after Gio's presentation, but I'm experimenting with that a little bit here. So that's why it's acting a little different than the default R console. But anyways, take a look at this second plot here. So yeah, anything you can think of, it's really up to your creativity about how to plot this data. So I think this is like basically total UMI or some UMI here by group. So yeah, I think these are sort of similar. I mean, I'm mostly just trying to convey the idea about how this package works rather than exploring this data in particular. Total features per cell is pretty similar. So here's, I guess, where we are doing something different. We're using a new function here. So this join features function, I had briefly mentioned in the beginning, Since I keep saying we're returning the call data of the object, right, as a tibble. And so this join features actually joins in the genes as well in sort of this long format. So actually I'm going to, before we plot this, I just want to show what this looks like when we just join in the features, it just warned me about. So I believe this warning actually, so it's saying like join features produces duplicate cell names that accommodate the long data format. So that means like for each gene, there's also each cell. So you see each cell will repeat twice here. And in this case, yeah, I guess this warning is sort of important because it's signifying that instead of returning a single cell experiment, it actually has to create a new tibble, a real tibble, right? It says a tibble here instead of that abstraction thing that it normally says. And so this is sort of one of the exceptions where it's not an abstraction, it's a real tibble. Anyways, so yeah, the idea is that for each cell, we have each gene, and then we have the actual counts. So it's taking the values from each assay. So in this case, we have the counts and we have the log counts. So this is like ggplot, as you may know, like really likes taking data in long format. So that's why they provide it this way. And so once you have it from here, yeah, we can go ahead and actually produce the full plot here, again, giving us that warning. And yeah, let me make sure I'm properly describing what we're doing here. So we're taking our features and we're taking our groups here. So it's just plotting the counts of these genes by group here. So this would be one way to summarize some like if you're interested in a particular set of genes. I mean, I guess the other option is like you can, in theory, print this whole. It would only be feasible for. Let me just type this down here. I believe it's all equals true. If you do this, it prints all your genes. So this would be like basically, this essentially is most of a summarized experiment object as a tibble, really, because it has every cell and gene combination followed by the counts. In practice, this would be an absolutely gigantic tibble, and you probably, just for memory reasons, this would not be an efficient thing to do in a real data set. I mean, this is real, but it's a very small subset, right? If you would multiply the actual rows by the columns in a real object, it would be way too big. But that is an option to print all your genes here. So they show how you can apply most of this application stuff. I guess we will run it so that we can do some stuff at the end. So I'll sort of speed through this section, but just to describe what I'm doing. Basically, they're doing some ordinary pre-processing and like clustering and stuff with the single cell experiment. Nothing here is really related to the tidy single cell experiment package for now. And when it is, I'll get back to that and really explain it in more detail. But for now, I'm just going to sort of run this code so that we can work with these objects here. So we're getting the top variable genes. We're running PCA on those genes. Yeah, so on a normal data set, maybe we would take this warning a little more seriously. But for this, we're working with a small data set and we're warning about similar values and lack of convergence. But for now, we'll just kind of skip over that and assume our PCs are good. And so actually, this object already had PCs in it, but in any case, it has PCs over on the right here. And actually, I think this is something I should clarify for myself. So normally the PCs would be in like the reduced dimension slot, not the call data. So that's what I'm a little bit stuck on here. Still learning this package as well. So actually, that was something I was not clear on. I think I must have misspoke because it does appear to be printing both the call data and the reduced dimension slots. Because if I just look at the call data, I don't see PCs here. Whereas the visualization that gets printed, if we just print the object, does show PCs. So looks like it's more than just the call data. So I guess I misspoke there. But yeah, I guess any column-wise information, really. Okay, so we did our variable genes, we did PCA, and now we can get to sort of the plotting here. So here's where we can sort of use our dplyr verbs. We can directly convert the the single cell experiment to a tibble. Although I don't see why that's actually, in fact, I think this will run if you don't do this. So I'm going to test that real quick. But after that, we're selecting the PC. variables, and then we're doing a GG pairs plot. So I'm curious. I don't think you need this as table, but I'm going to try it without it. Data must be a data frame. Okay, interesting. Okay, so this is for the GG pairs function, right? Because select is fine. Like we've defined select for single cell experiment objects, but we have not defined GG pairs. So that's why they do that. Okay, that makes sense. And go ahead and check out this plot here. So yeah, GG pairs. I don't know if we've done like R sets on this. I think we may have, but gives you a huge amount of information across different combinations of variables. So in this case, combinations of PCs. I guess this would be a lot to interpret right now, but any big takeaways? There's not. Oh yeah, I mean, no correlation, right? Because PCs are orthogonal to each other. So I'm not sure this would be like a normal. I'm not sure why they picked this actually. But okay, so this is PCs. I'm going to go ahead and run this clustering as well, for completeness here. Again, they're reordering the call data columns here. I'm not sure why it's printing like this. Anyways, that's kind of off topic. So I guess here they're using the count function to count the number of cells per cluster per group. So let's print that here. And again, giving us this warning that like some functions, it doesn't really make sense to return a single cell experiment. They do have to actually produce the real tibble rather than just viewing things as a tibble. So that's still something I'm like, I feel like I don't have a comfortable grasp on, like when things are being produced in memory versus like, I don't know. I guess when things are in abstraction, things can be maybe more confusing to understand. Like it's more of a black box rather than like, well, anyways. So from here, we can, looks like they're identifying some marker genes. So this is not really tidy single cell experiment code here. So I'll just run through this. Okay, so now producing a heat map here. Again, we're using this join features function to give us a long, again, just as a reminder of how this works. We get the actual table and it's in long format where we have each combination of cell and feature as well as the assays or like the counts for that combination of cell and feature. And then you can do anything you want with it. We're in this case grouping by the labels and making a heat map here. Yeah, so we have each our marker genes. It's pretty hard to see, but we do have our markers on the y-axis, and then we have genes or our cells. I mean, so that's the barcode, and then this is, I guess, a heat map of expression. So yeah. See if there's anything else we want to do here. This is a little more advanced. Actually, I haven't really worked with Nest here, so I don't think I'm going to go do this. But if you're familiar with Nest verb here, this might be interesting to check out. But I'm going to just skip over it. So I guess for now, I guess if there's any questions, we can take a little like break here. But yeah. Any questions?
Well, I think that it's interesting to have an utility like this to manipulate and plot things in an easy way. But it's not clear to me when the manipulation is occurring in place or it's occurring, in memory.
Yeah.
Something like that. It's the part that I'm missing here. Yeah. Just slightly I need to scroll a bit more, but this is the part that I don't fully understand.
Yeah, actually, I think that is the most confusing part. So I think in general, when you're viewing, the object and doing stuff like that, it's not creating anything new. Most functions, I think, return a single cell experiment. So it is creating copies of things. If you do like a mutate and you add a call data column, I think since it has to return a single cell experiment, it is making a copy, I believe. And then I guess we went through a couple cases where I guess it really depends on the function, which makes it a little confusing because some functions, like when you use join features, for example, then it actually creates a real tibble. So it's not making a new single cell experiment or anything, but it is making a new tibble, which can be large.
They didn't add anything saying in what, let's say, collection of functions they are creating new objects or not, right?
So, I mean, if you're talking about like which,
Yeah, because they have a collection of functions there. So for example, when you select when you add in the table the sample in your examples,
yeah,
it looks like they really add the column to the call data.
yeah, it does.
Yeah, so
yeah.
so I was wondering if they mentioned something about under a particular collection of functions they are adding functions, or is just something related with something else? I mean, would you say depending on the function or?
Yeah, to me, I mean, I think from looking sort of like briefly, it seems like it's kind of hard to know. Like, there's not a clear indication as to whether which things are making new single cell experiments versus like basically, I guess it's not clear. And it really depends on the function, unfortunately. So it is kind of like difficult to understand what's going on under the hood if you're just applying a particular function.
The other thing that I'm curious to how it's working in the deep, if for example that you have the PCAs side to side to the whole data, no?
Yeah.
So we know that these are in another side as well as the TSNEs that they have together. I mean, nearby to the PCAs.
Yeah.
So what is this kind of table? It's just grabbing the different sides and it's just joining the information, but it's a real table.
I think so. I wish I'd asked more questions. This was something that they had talked about more a couple of years ago in the Bioconductor conference in Boston. But it seems like it's an abstraction where it's not actually making a real tibble in memory, and it's just sort of pointing to the existing object, is my understanding. So it's not like actually creating a table by combining call data and all of the reduced dims. It's like pointing to the call data and the reduced dims and showing you something that looks like a table, is my understanding.
I mean, it looks convenient.
Yeah.
Just to understand a bit what's happening. Yes.
So I think it is fairly like memory efficient in that sense. But yeah. Cool. I think one other thing I wanted to mention is that like on an earlier package we had talked about, like in another session, was the dplyr package. And that was sort of, I mean, it's not really similar, but I think there's some like analogies here about like the dplyr. I think this is basically what I'm trying to say here is that I think this, you can maybe trust the implementations of this a little more easily than the implementations in dplyr. So if you remember, that was the package for translating dplyr code into data table code. This is a little bit different in terms of like they do have to explicitly define each function. And so you might think, well, what if they don't define it correctly? I guess that's technically possible. But I think in this case, it's a little easier to define these functions. I was looking at like one of my examples that had failed with dplyr was sort of actually it was an inner join. So I just want to like maybe, there's inner join here. Maybe I'll show it in actually the code. I was looking through the actual scripts and how they implement some of this stuff. So I think it should be here, right? Inner join. Yeah, here's inner join. Okay, so actually it calls this method that they call join factory. So let me take a look at join factory. Join factory, here it is. And so I think this is a little bit easier from a developer standpoint. I think it's a little bit easier for them to implement this correctly than it is for dplyr to implement dplyr verbs correctly. And the reason I say that is because they can generally, like I saw, they just use a ... here when they're sort of invoking the join function, in this case, inner join. And so I had used like a sort of a special weird parameter to inner join related to using multiple matches, and that had failed on dplyr. And that's because they have to, for every single parameter, they have to explicitly implement the logic. Otherwise, it's not going to work correctly. And so that's a huge thing to demand from developers, right? To do that correctly and completely. Whereas here, they can sort of take advantage of functions that already are implemented. And so I don't know if that makes sense, but basically, I think these are easier to implement reliably and in a way that you can trust that they are doing what they're supposed to be doing. Yeah.
Makes sense.
Let's see if I can find. Yeah, in fact, I was looking at this join here in the documentation, and I noticed, I think, sort of related to Cynthia's question. So it says from value, it says an object of the type same type as X. And in other words, like if you pass a single cell experiment, it would return a single cell experiment. But then I like look down in the examples and where is this? Was it inner join? It may have been a different type of join here actually. It was full join. Sorry, let me go to full join real quick. It does say the same thing about value, I believe. So full join says it returns a single cell experiment if you pass it one. But then I saw like an example where it's like returning a tibble. So it's like, it is kind of confusing. In other words, I think like it could be made more clear in the documentation here, like what's being returned and like when new things are being created versus, yeah, that kind of thing, I guess. So yeah, I think that's a little bit of a black box maybe, unless you really go in and try to, you can do what I did and sort of like look at the code, but that's not always possible for doing it for every function. Yeah, I guess as a final note, there's also a tidy spatial experiment package. So, and tidy summarize experiment. So there's a bunch of different summarize experiment derivatives that have tidy implementations. So this is just one I'm describing here, but you might want to check those out. I think they're very similar. Like the tidy spatial experiment one has some functions for like grabbing. You can circle an ellipse of points spatially and stuff and plot that or do whatever you want with that. So it has some extra utilities, but for the most part, it's like a similar idea.
I'm on the same group.
Yeah, I think so. I think it's sort of a community effort, but I think it's being organized by like maybe Mike Love and Stefano and others.
I'm trying to guess if they defined like a standard to try to implement these small packages. These packages.
Yeah, they have some GitHub page for tidyomics challenges, and they are trying to make a community effort where they're saying like, here is something that we want to be tidy, this type of bioconductor object that we wish had a tidy implementation, and like here, like go ahead and work on it if you are interested, basically. So they have a page somewhere. I can try and find that, but they are trying to sort of standardize things, I guess. But yeah, I think that's all I had for today. Because we already covered some questions, but if there's any more, I'm happy to answer.
Thank you, Nick. Sounds like you might want to ask them a few questions, right, about like the memory stuff.
Yeah.
Or like this feedback that you have about like clarifying some things in the documentation.
Yeah, it's true.
Right. I'm sure that if you let them know, they'll fix some of these things about the documentation.
Could you share some of these links, or are you going to add it to the Google?
So I think everything should be sort of linked from. I linked this main vignette. And from the vignette, I checked out the source code and the bioconductor, or just the source code, I think. But it's linked there, so hopefully that should be.
You show one screen where you have all the packages together. The group for options at the beginning of TikTok.
This? Or sorry?
No, not that one. I don't remember.
All the functions.
I can look for that in the video, in the recording. So
okay.
Works.
Yeah, I want to link everything. If you're interested, I want to make sure I'm linking everything, but I'm not sure.
In general, there, Nick, what I do is like make these Google Docs that just have the links in a short description.
Oh yeah, that's true.
If you're like opening a bunch of things, even if they're all linked here from this page.
Yeah.
Yeah, that one.
That could be useful a bit too. Have you tried the tidy spatial experiment?
Not thoroughly. I went through their tutorial a little bit, and that's about it. But it seems very useful just because, like, they're not making a new object, so you don't have to worry about anything breaking or anything. It's just like it is a spatial experiment just with like the functions that work. So, and they claim to implement every dplyr verb, so that's a big claim. But yeah, cool.
They use something like TT. They have made TT service, which is tidy transcriptomics, where they are implementing all this aggregate cells for pseudobulking and those functions.
What package?
The same authors, they have this service for tidy transcriptomics software suite.
So how does that work?
I'm not following.
Like they like in the references that you had shown, they have some methods which they have implemented for this tidy single cell experiment. The GitHub page that you were showing.
Yeah.
So like some methods they have imported from like dplyr, tidyr. So they have different sections, and one methods.r script, it has implementation of the methods that they have built. So that is under TT service. tidy transcriptomics.
So what kind of objects is it like working with?
No, I'm not. I mean, I was looking for this, and I was looking for the aggregate cells. Is it like is it they're importing from somewhere like suitable DG or like any of the other packages? But looks like
You mean
they're
scRNA?
suitable, yeah, like from scRNA or like from masquerade packages. But they have written their own function.
Have you tried it with any of the AGF5 back data?
No. Yeah, I guess.
I don't know, like give it some of these things like just blow the memory up, or maybe not as much.
Yeah.
Right? Like, it's mostly for the assays, right? At that point.
Yeah, because I think you have to explicitly, it seems like you have to explicitly join in the genes, which then joins in the counts as well for the assays. And if not, it doesn't load it, maybe.
Yeah, thank you, Nick. Any more questions, comments? I think that's it. Well, see you. Have a good weekend, everyone.